Hello all, let's start section 3.2. 3.2 is the product and quotient rule. Let's first talk about product. From chapter 2, from limits, the product was so easy. If you are, for example, if you had two functions, the limit of two functions, the limit of f of x, g of x, f of x times g of x, as x approaching to a. This limit was so easy to handle. The formula told you there, take the limit of the first function, the limit of f of x, as x approaching to a, then times the limit of g of x as x approaching to a. That was the rule. When we talk about the product and derivatives or in differentiation, it's not the way that we did in limit. How it works when we do differentiation. Look, if I have two functions, one of them f of x and the other one g of x, the derivative ddx of f of x times g of x, how we do this derivatives if you have a product. What you do, you write your first function, f of x. Then you multiply your first function with the derivative of the second function, ddx of g of x. Then always the sign in between plus. When you come to the second part, you write your g of x, your second function, and you take the derivative of the first function, ddx of f of x. This rule, we call it the product rule of derivatives, or the product rule of differentiation. In your book, they use the notation of the prime notation. It's like this in your book, ddx of f of x times g of x equals f of x g prime of x. G prime of x means ddx of g of x, right? It's the same. Plus g of x f prime of x. Both of them is the same rule, same thing. Here it's, as I told you, it's the Leibniz notation. I like it more. I don't know, maybe it's only me, because ddx notation, I told you, it's an operational notation. It helps a lot when you handle the problems. You can write them, you know where to go. I like it that way, but some professors, some people, they prefer the prime notation. Which way is easy for you to understand and memorize? Choose that way. Now, I'll do some examples for you for the product rule, correct? Let's practice this rule in product. Example number 1. For example, if f of x is equal x and g of x is equal to 2x squared, they are asking you here to find ddx of f of x times g of x. It means find the derivative of this product. How to proceed? ddx of f of x times g of x, it means they are asking you to find the ddx of f of x, which is x, times g of x 2x squared. It means look for this derivative. To be honest with you, a lot of students, they are asking me this question. Okay, professor, why we should apply the product rule here when it's more easier to first multiply x with 2x squared, then take the derivative? Yes, that's the easy way. But only maybe this for this problem, because it's so easy. There are problems, there are products that if you multiply, it becomes too long, or even it's so difficult to multiply. That's why we have the product rule. I know in this example, why not? X times 2x squared gives you 2x cubed, and easily you learn the basic rules of derivatives. The derivative of 2x cubed is 6x squared. Easily you can find the answer, but I will go this way with you here, correct? The way that apply the product. Then the dx of x times 2x equals, look at the formula, f of x, your f of x is x, times d dx of 2x times g of x, then plus sign your g of x, which is 2x squared. I'm sorry, the page is gone. I have to find the page for you. Then g of x, which is 2x squared, times d dx of f of x, which is x. Do you see the beauty of d dx when you work? It tells you what to do in the next step, where to start, because a lot of students get confused. Okay, I set it like this. Now, what is my next step? Where to work? Next step is keep your x. Wherever you see d dx in front, it means first take the derivative of that function. What is the d dx of 2x? The d dx of 2x is x. Then x times, the d dx of 2x is 2, not x, times 2. Plus, keep 2x squared. d dx of x is 1. Now simplify. 2 times x gives you 2x. Plus 2x squared times 1 gives you 2x squared. Good. Let's do another example. F of x equals, here you go, a bigger function, 2x squared minus 1 times x cubed plus 3. They are asking you here to find f prime of x or find the first derivative of this function. Very easy, very easy. This should be your notation like this. F prime of x equals, first write down like this, d dx of this product, 2x squared minus 1 times x cubed plus 3. Now, if you focus, this is one function, this is another function. Easily you can apply the product rule. F prime of x equals the derivative of the first function, which is 2x squared minus 1, d dx of the second function, which is x cubed plus 3 plus your second function x cubed plus 3 d dx of first function 2x squared minus 1. Now where to work? We work in a place that we have d dx in front of it. It means first we find our derivatives. Keep 2x squared minus 1. d dx of x cubed plus 3, it's the addition rule, right? You take the derivative of x cubed and also you take the derivative of 3. The derivative of x cubed is 3x squared plus the derivative of 3 is 0. If you remember from previous lecture, the derivative of a constant is 0. Plus, keep x cubed plus 3 times d dx of 2x squared gives you 4x minus d dx of 1 gives you 0. Now we simplify. 2x squared minus 1 times 3x squared plus x cubed plus 3 times 4x. Now you can distribute 3x squared here and you can distribute 4x here, and at the end, if you have like terms, you can combine like terms. 3x squared times 2x squared gives you 6x to the power of 4. Minus 3x squared times 1 gives you 3x squared. Plus 4x times x cubed gives you 4x to the power of 4. Plus 4x times 3 gives you 12x. Now, as you see, 6x to the power of 4, 4x to the power of 4, they are like terms, I will combine them. 6x to the power of 4 plus 4x to the power of 4 gives you 10x to the power of 4 minus 3x squared plus 12x, final answer. Even, you see, I'll accept this as a final answer, but even you see here that x is common in all of them. Even you can factor x if you want to. You can write this way. X parentheses 10x cubed minus 3x plus 12. Both of them is the same. This is the factor form. This is without factoring. Let's do another example for you. Example number 2 or number 3, whatever the example is. F of x equals x cubed parentheses square root of x plus 1. Here you see even you cannot distribute x cubed first to make it simple. Yes, and second step or third you can do it, but there is no need to do those kind of stuff. Correct? We are looking for the f prime of x. Differentiate, right? F prime of x equals d dx of, keep your x cubed, times, here instead of a square root of x, we can write x to the power of 1/2. If you focused on my first lecture on the basic rules of derivatives, I told you every time that you see a radical, change it to exponential notation. Plus 1. Now product rule. F prime of x equals first function x cubed d dx of second function, which is x to the power of 1/2 plus 1, plus second function, which is x to the power of 1/2 plus 1, d dx of the first function, which is x cubed. Now, Again, we handle the places that we have d dx. F prime of x equals x cubed times d dx of x to the power of 1/2. It becomes 1/2 x to the power of 1/2 minus 1 gives you negative 1/2. And the d dx of 1 gives you 0. We are not writing even in this example that's 0. Plus x to the power of 1/2 plus 1. d dx of x cubed is 3x squared. Now we can distribute f prime of x equals 1/2 x cubed. Look, here I'll do it in a corner of this notebook. X cubed times x to the power of 1/2. If you remember from your algebra, bases are the same. You take one of the bases and you add the top. It means 3 minus 1/2. It means it gives you x to the power of 5/2, right? Then 1/2 x to the power of 5/2 plus same thing, distribute here, it gives you 3. Again, look, x to the power of 1/2 times x squared. You take one of the x's and it will become 1/2 plus 2. Actually, it's 2 over 1. You have to multiply top and bottom with 2. It means 4 over 2. 1 plus 4 gives you 5/2. X to the power of 5/2. 3x squared times 1 gives you 3x squared. Now, you see here and here, they are like terms. 1/2 plus 3 gives you 7/2, right? F prime of x equals 7/2 x to the power of 5/2 plus 3x squared, your final answer. This was all about the product rule. What I'll do here to make it easy to watch, I'll make this video only for product rule. Next video will be the quotient rule. I'll stop the lecture here. See you all in the next lecture, which is quotient rule.